Good morning. Happy Monday. The following session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu, and I'll respond as soon as I can. Apparently, I can't talk today. All right. So today we're going to take a look at section 6.6. But before we do that, I had one person submit some questions. So we're going to go over those questions here, which is from section 6.4, starting with number 18. A reminder, your number 18 may not be exactly like this, but it will be similar. It says factor. If the expression is not factorable using integers, enter, as in write in, prime. So we have 3 p to the 4th minus 48 q to the 4th. Well, the first thing we can do is take out a greatest common factor of a 3. So taking out a 3, we get p to the 4th minus 16 q to the 4th inside. Okay, but what's inside the parentheses is the difference of two squares. We could write p squared squared minus 4q squared squared, because the 4 squared would give you the 16 and the q squared squared would give you the q to the 4th. So now what I've got is 3 times p squared plus 4q squared times p squared minus 4q squared. But we aren't finished yet. Excuse me. Hang on here. Let's see. This won't factor any further. That won't factor any further, but this one will, because that's also the difference of two squares, which is p squared minus 2q, the quantity squared. So we get 3 times the quantity p squared plus 4q squared times p plus 2q times p minus 2q. And even though that last term is a binomial with a subtraction sign, it doesn't have squares at both ends. So there's our final answer. Any questions on that one before we go on? All right, let's take a look at number 19 from 6.4. Number 19 says factor. If the expression is not factorable using integers, write prime. We have 36z squared minus 12z plus 1. So this is a trinomial, and it's in standard form, descending powers of the variable. There's no greatest common factor. But notice the first term is a perfect square. The last term is a perfect square, and there is a plus sign in front of the last term. So let's see if it is a perfect square trinomial with two identical factors. 36 would have to get broken apart 6 and 6. Z squared would be a z and a z, and 1 would be a 1 and a 1, but we have to have a minus sign in the middle to get minus 12z in the middle. Does that give me minus 12z in the middle? It does. So that's the correct answer, or we could write it 6z minus 1, the quantity squared. So either one of those two ways would be the correct way of looking at it. Any questions about that? All right, that takes us to number 25. Oh, I want to point out, you could use grouping on this, but it would take much more time. So it's easier to check to see if it's a perfect square trinomial before going on. All right, this is number 25. Choose the correct method to factor the following completely. Rx minus Sx plus R minus S. Well, this has 4 terms. There's no greatest common factor for all 4 terms. Typically with 4 terms, we use factoring by grouping. So let's see if we can group it the way it is. The greatest common factor of the first two terms is x with a remainder of r minus s. So over here, I would need r minus s. And if I take out a plus 1, that works. So I get r minus s times x plus 1. And there you have it. Okay, any questions there? 6.4, number 27. Choose the correct method to factor the following completely. 4y squared minus 256 z squared. This is a binomial. So I'm looking for the difference of two squares, but before I do that, I believe I can factor a 4 out. Let's see, what's 256? 256 divided by 4 is 64 z squared. Okay, now y squared would be y squared minus 64z squared would be minus 8z, which would be 64z squared. So I get 4 times y plus 8z, y minus 8z. And there you have it. Any other questions from anybody that's here right now before we go on to section 6.6? Okay, well then let's go on. So now, 6.6, there's nothing new here. It's just that rather than focus on a particular kind of factoring, they mix it all up. So what I want to do, first of all, I want to tell you that in the textbook on page 477, they have their general strategy for factoring polynomials, okay? I'm going to give you my general strategy, which is pretty much the same thing, but in my own words. So here it goes. All right. Point 5 is standard form. 1 is take out greatest common factor. 2 is different, or let's see what, okay, binomials, difference of two squares. 3 is trinomials, and I'm going to have, let's see here, subscript 1, 2, and 3. This is perfect square. This is x squared plus bx plus c. This is ax squared plus bx plus c, a, b, c, p, s. Don't worry, I'm going to explain all this if it doesn't make sense. 4 is factor by grouping. 5 is are you through, and 6 is check your work. Okay, now, so standard form, we've dealt with that, like descending powers of the variable. Why did I start my list with 0.5 instead of 1? Because 1 is take out the greatest common factor, 2 is binomials, 3 is trinomials, step 4 is factor by grouping, which is typically 4 terms. So that's why I do it that way. But standard form, take out the greatest common factor. If it's a binomial, look for the difference of two squares. If it's a trinomial, first look and see if it's a perfect square. Then if it's not, but it has a leading coefficient of a 1, we go back to section 6.2, product and sum. Then Roman numeral 3, if it's ax squared plus bx plus c, where a is not a 1, you can use the grouping method, ABCPS, or the trial and check method. Then step 4, if it's got 4 terms factored by grouping. Step 5, are you through? Can you factor it any further? Some of the ones we looked at. In fact, let's go back here and let's look at an example. This one, it factored, it kept factoring. So are you through, or have you factored everything you're supposed to? And finally, check your work. All right. Now, I'm going to refer back to this list as I go on and do examples. I'm just going to pull some examples from the book, but we're going to take it through that checklist. But there's one other thing I want to do here, and that is with a binomial, we don't care so much about standard form. We just care about, is it the difference of 2 squares? So standard form, I'm going to do this. I'm going to put a circle or circle it there. Well, draw an oval or whatever around it. Pretty much goes with trinomials. So it's a binomial. We don't care so much about standard form as if, is it the difference of 2 squares? And we'll look at that. Okay, so there's my list. And again, that same list is back there on page 477, just written in the author's language instead of mine. Okay. So now here come some examples. Let's see here. 6r squared plus 3rs minus 18s squared. Okay. Is this thing in standard form? Well, it is in terms of the variable r. It's not in standard form in terms of s, but if it ain't broke, don't fix it, right? So it's in standard form in terms of r, so that's good. Is there a greatest common factor? Yes, a 3. So we'll take out the 3. Okay. So now, what's inside is a trinomial. So going down our list, it was in standard form. We took out the greatest common factor. It's not a binomial, it's a trinomial. So we're going to look, is it a perfect square? Well, it's not a perfect square, is it? 2r squared, the 2 isn't a square. And then 6s squared, the 6 isn't, and there's a minus sign instead of a plus sign. So it's not a perfect square trinomial. How about in the form x squared plus bx plus c? Nope, it's not in that form. The leading coefficient is a 2. So I'm going to use grouping. Okay, so I'm going to go down here to this thing, grouping. So a is 2, b is 1, and c is -6. The product is -12, and the sum is 1. How about 4 and -3? 4 times -3 is -12. 4 plus -3 is +1. So the numbers 4 and -3 have a product that's -12 and a sum that's +1. So now I'm going to take the trinomial in parentheses and split it up. I'm going to make it plus 4rs minus 3rs minus 6s squared. And I'm going to use grouping. So 3 times, let's see, 2r squared plus 4rs, the greatest common factor there would be 2r. So we get r plus 2s. All right, 2r squared, yeah. And then over here, I'm going to get r plus 2s. And I'm going to take out a minus 3s. That'll give me, let's see, that would give me minus 3rs minus 6s squared. Yep, that works. So I've got 3 times r plus 2s times 2r minus 3s. So there is my final answer. Now, let's go back to this list. Are you through? Check your work. I can't factor anything any further, right? There's a binomial, but it's not the difference of two squares. To check my work, I'd multiply everything back together. So let's see here. This would give me 3r plus 6s times 2r minus 3s. And that's going to give me 6r squared minus 9rs plus 12rs minus 18s squared, which would give me 6r squared plus 3rs minus 18s squared, and that matches that, so it checks. Okay. Any questions about that problem? Okay. Hang on a second here. Let's see. Here. Okay. How about this one? T minus 90 plus t squared. Well, this is a trinomial. Is it in standard form? No, it's not. So let's put it in standard form. T squared plus t minus 90. Is there a greatest common factor? Nope. Is it a binomial? Nope. Is it a trinomial? Yes. Is it a perfect square? Well, t squared is a perfect square, but 90 is not. But it does have a leading coefficient of a 1. So we're looking at this right here. Okay. So it's going to be t, and the product is negative 90, and the sum is a positive 1. So how about 10 and negative 9? The product is negative 90, and the sum is 1. So plus 10 minus 9. T minus 9 is a binomial. 9 is a square, but t isn't a square, so we can't factor it any further. Let's check our work. T squared minus 9t plus 10t minus 90, t squared plus t minus 90. Check. Any questions on that one? All right. Let's see. 8m squared n cubed minus 24m n to the fourth. This is a binomial, so I'm going to look for the difference of two squares. But before I do that, I want to see if there's a greatest common factor, which there is. 8m n, whoops, too many humps on that camel, 8m n cubed. So this would give me m minus 3n. Well, that's a binomial in the parentheses, and it's a difference, but it's not the difference of two squares. So that's all I can do. Now, it is not prime because we did take out a greatest common factor. Okay, so it's not a prime. All right, let's see here. How about this one? AB squared minus 4a plus 3b squared minus 12. 4 terms. Is there a greatest common factor for all 4 terms other than a 1? The answer is no. But let's try grouping. So I could take an a out of the first group and have a b minus 4, or excuse me, a b squared minus 4, which means I'd have to have a b squared minus 4 over there. Oh, plus 3. Yeah, that works. Greatest common factor is a b squared minus 4, a plus 3. Oh, but b squared minus 4, that's the difference of two squares. B plus 2, b minus 2, and then a plus 3. So are you through? It ain't over till it's over. Make sure. Okay. And let's see here. How about this one? A squared plus 8a plus 3. This is a trinomial. It's in standard form. There's no greatest common factor. It's not a perfect square. The first term is, but the last term isn't. But it does have a leading coefficient of a 1. So A, product is 3, sum is 8. So any questions about that so far? All right. Well, if the product is 3, it's got to be 3 and 1 or -3 and -1, but it can't be negative because the sum's positive. And that gives us 4. It's prime. Okay, can't do anything. Okay. How about this one? U squared minus 18u plus 81. It's a trinomial. It's in standard form. There's no greatest common factor. Oh, it could be a perfect square because it starts with a square and ends with a square, and there's a plus sign in front. But the middle term's negative, so it'd have to be that. Does that give me minus 18u in the middle? It sure does. So there's the answer, or you could write it u minus 9, the quantity squared. Any questions there? Okay, let's see here. How about this one? 28 minus 3m minus m squared. This is a trinomial. It's not in standard form, so let's put it in standard form. The leading coefficient is not a 1, so let's factor out a negative. I mean, the leading coefficient was a -1, so let's factor a negative out, okay? So now we've got that trinomial. It's going to have a product that's -28 and a sum that's 3. How about 7 and -4? That would do it. Okay. Any questions about that? Let's see here. 12x squared minus 12. This is a binomial. Greatest common factor is at 12, so we've got x squared minus 1. But that is the difference of 2 squares, x squared minus 1 squared. So there we go. Okay. Question? Oh, all right. 6x squared minus x minus 16. This is a trinomial. It's in standard form. There's no greatest common factor. It's not a perfect square. It doesn't have a leading coefficient of a 1, so I'm going to use grouping. So A is 6, B is -1, C is -16, the product is -96, and the sum is -1. That looks like a 5. That's supposed to be an S. So I'm looking for two numbers whose product is -96 and whose sum is -1. I'm going to go over here and start this list so I have more room. To get a negative product, we've got to have a positive and a negative, or a negative and a positive. But the sum is -1. So the negative number is slightly more powerful than the positive. But the negative has got to be a more powerful number. So how about -96 and 1? Well, that would give us a sum of -95. Way off. How about if we split the first one in half and double the second one? That would give us a sum of -46. Split this one and double that one. That would give us a sum of -20. We'll split this one and double that one. That would give us a sum of -4. Okay, do you see what I'm doing there? By splitting the first and doubling the second, I'm coming up with a pair of numbers whose product is still -96, and I'm getting closer and closer to -1. Well, if I cut this one in half and double that one, now all of a sudden we've got our positive number bigger than our negative. We predetermined that the negative number had to be bigger. So where are we at? I need a number that's, this is going down and this is going up. I need a number that's positive, but bigger than 8, that goes into negative 96. Let's see. How about 9, 10, 11, 12 goes in, but again, that doesn't work because then our larger number is positive. 9 doesn't tend to, there's nothing that goes in there. So what are you thinking? It's prime.
I thought for it to be prime though, that the last portion had to be a positive, like that had to be a positive 16.
Oh no, that's if it's a perfect square.
Oh, right. Gotcha.
Yeah, I know. Prime, perfect square, they both start with letter P and it's Monday. I know. Yeah. Okay. Let's see here. How about this one? 16d squared minus 56dz plus 49z squared. Here is a trinomial. It's in standard form in terms of the variable d. There's no greatest common factor. Is it a perfect square? Well, the first term squared, the last term squared, and there's a plus sign, so it very well could be. So let's go in with the assumption it is and see if we can get it to work. So 16d squared, we'd have to have a 4d and a 4d. 49z squared, we'd have to have a 7z and a 7z. But my middle terms, the O and the I, outside and the inside, have to be negative. Well, let's see, that would be negative 28 dz minus 28 dz would be negative 56 dz. Bingo. So there it is. Or you could write it as 4d minus 7z, the quantity squared. So there's a perfect square trinomial. Okay. Let's see here. How about this one? X to the 6th minus 4x cubed minus 12. Well, this is a trinomial and it's in standard form. There's no greatest common factor and the leading coefficient is a 1. So how would you split up x to the 6th? It would have to be x cubed and x cubed. So the product would be negative 12 and the sum would be negative 4. How about negative 6 and 2? And there you go. Neither one of those is the difference of two squares. Because this one, those aren't squares, the x cubed or the 6. Okay. All right. How about this one? 24 minus x cubed plus 8x squared minus 3x. So first thing we're going to do is put this thing in standard form. Negative x cubed plus 8x squared minus 3x plus 24. And now I could factor out a negative 1. Do you want to do that or do you want to leave it? You can do it either way.
Factor out the 1.
Factor out the negative 1. Okay, so negative 1 x cubed minus 8x squared plus 3x minus 24. Okay, I'm going to use grouping because there's 4 terms inside. So negative 1 Greatest common factor would be x squared and then an x minus 8. So then I have an x minus 8 and a plus 3. So I have -1, x minus 8, x squared plus 3. All right with that? Okay. How about this one? 25b squared plus 14b plus 49 25ths. Ugh, what's going on here? Well, that's a trinomial. It's in standard form. There's no greatest common factor. Oh, 25b squared is a square and 49 is a square over 25 is a square and there's a plus sign. So let's see, how would we break that up? 5b, 7/5, 7/5. Square root of 49 is 7, square root of 25 is 5, and it's got to be plus in the middle. Well, I'm going to get 25b squared plus 5b times 7/5 plus 7/5 times 5b plus 7/5 times 7/5. Well, that would be 25b squared. Here the 5s would reduce down to 7b and the 5s would reduce down to 7b, and we get 49 25ths, combining like terms, and we, whoops. So we get that, or we could write it like that. So there's another perfect square, kind of a tricky one though with the fractions involved. How about this one? X to the 4th minus 13x squared plus 36. Okay. This is a trinomial in standard form. No greatest common factor. It could be a perfect square. But it would have to be negative. Wait a minute, that doesn't give us negative 13x squared. Does that mean it's prime? No, it just means it's not a perfect square. So now we go back to the drawing board. Well, it has a leading coefficient of a 1. The product is 36 and the sum is negative 13. How about negative 9 and negative 4? But wait, that's the difference of two squares. So is that. Wasn't that fun? Fun.
So what's the, besides just knowing your multiplication tables, what's the best, is there like a fast method of figuring out if a number is square? Like say A1, right? It's 9 by 9. But is there, if you don't know off the top of your head, like what's the quickest way to figure that out?
I suppose on your calculator, take the square root of it. So let's say, for instance, 41. So I take the square root of 41, and if I do that, let's see here, the square root of 41, I get 6.4. But if I take the square root of 49, I get a nice number. So yeah, I guess take the square root of it on your calculator.
Roger that.
All righty. Let's see here. How about this one? X squared y squared minus 6xy minus 16. Well, this is a trinomial and it's in standard form and there's no greatest common factor. Now, when I say it's in standard form, think of the variable as being xy, because there's x squared y squared, which is like xy squared minus 6xy minus 16. So it's got, if we think of xy as the variable chunk, we've got it squared, first degree known. Okay. So now it's not a perfect square because there's a minus sign there. Whoops. If there was a plus sign there, it might be. So now I'm going to break it up. XY, XY, product is -16, sum is -6, -8, and 2. This is a binomial, but it's not the difference of two squares. It doesn't factor any further. So there's your final answer. Okay with that? Let's see here. How about this one? X to the 4th minus 2x squared minus 8. This is a trinomial. It's in standard form. There's no greatest common factor. It's not a perfect square, but it does have a leading coefficient of a 1. So x squared, product is -8, sum is -2, -4, and 2. Oh, x squared minus 4, that's a difference of two squares. X squared plus 2, that doesn't do anything for us. So there we go. Okay, how are we doing? Let's see here. I think I already did that one. Nope. How about this one? AE plus BF plus AF plus BE. Well, standard form is kind of crazy on this one, right? It's like, it's not really, oops. It's just not going to happen. But you can see it's 4 terms. So let's try factoring by grouping. Oh, there's no greatest common factor either, right? Other than just a 1. So let's try factoring by grouping. Well, this is all I can take out is a 1. That's not going to work. What if I rearrange the terms? Let's see. How about if we put the ones with A together and then the ones with B together? Sorry, just wanted to write them so I could actually read them so that you could too. Well, now grouping, we take out an A and we'd have an E plus F. And over here, we'd have to have an E plus F, and we take out a B. Well, I could get from there to here, but better would be this. So what have I got to do? I've got to turn these around. So B, E plus B, F. So now I've got A times E plus F, E plus F plus B, E plus F, A plus B. So I could do it, but I had to juggle things around and try to figure out how to get them so that things matched up nicely. Okay. One of the biggest mistakes that students make on this upcoming test is they think something's prime when it's not, because they try a couple things and it doesn't work, so they just give up and think, oh, it must be prime. So be really careful with that. 12x squared plus 52x plus 35. Here we have a trinomial in standard form. There's no greatest common factor. It's not a perfect square, and the leading coefficient is not a 1. So I'm going to use grouping. A is 12, B is 52, C is 35. The product is, wow, let's see, 35 times 12 is 420, and the sum is 52. Sometimes numbers just jump right out at you. Can you see what the two numbers are going to be? Anybody? How about 42 and 10? Now, let's say they don't jump right out at you. How would you get that? Okay, so let's go the long way. They've got to both be positive, right? Because positive times positive would be positive, and positive plus positive would be positive. So let's go 420 and 1, which would be 421. Let's go 210 and 2, which would be 212. 105 and 4, which would be 109. Well, I can't cut 105 in half. Can't take out a 2. I could take out a 3, and I get 35 and 12, which is the originals right there, which is what? 47. So what do I know? 40 or 52 is between there, right? You see how I'm getting that? So one of my numbers has to be between 105 and 35. I don't want to look at all those, but how about between 4 and 12? So what do I got? I got 5, 6, 7, 8, 9, 10, and 11. Well, let's see. 5 goes in. How many times? 84. That would be what? 89. So that's too big. 6 goes in 70 times. 6 times 70, which would be 76. That doesn't work. 7 goes in 60 times. That would be 67. No, that doesn't work. Okay, let's see here. 8, does 8 go into 420? 420 divided by 8. No. Does 9 go in? 420 divided by 9. No. 10 goes in. There we go. 10 and 42. Okay, so that's doing it the long way, but it still gets you there. Okay, so my two numbers, 42 and 10. So I'm going to get, let's see here. Can I erase all this stuff over here? You okay with that? You can always go back and look in at the video, but so I've got 12x squared plus 42x plus 10x plus 35. Factor by grouping. Greatest common factor is going to be 6x. 2x plus 7. 2x plus 7 plus 5 outside. 2x plus 7. 6x plus 5. And you get that. Okay, let's see. How about this one? I don't think I did this one before. 12x squared plus 14x minus 6. Trinomial, standard form. Greatest common factor is a 2. 6x squared plus 7x plus 3. So I'm going to use grouping on that. A is 6, B is 7, C is -3. The product is -18. The sum is 7. How about 9 and -2? So 6x squared plus 9x minus 2x minus 3. Greatest common factor, 3x, 2x plus 3, 2x plus 3 minus 1, 2x plus 3, 3x minus 1, and it's wrong. What did I forget? And I did this on purpose because students do this a lot. What did I forget? That, which is why I should have drug it along with me. Okay, so take the time, bring it along so that it's there at the end. Because I see that mistake, a lot of people don't give me that, like, well, what's wrong with that? Well, you left the 2, got rid of it. Okay, all right, I've tortured you enough for one day. I think you'll agree. I will be back at 1:15 with an office hour. Other than that, Have a great day, and I'll see you tomorrow. So I'll stop the recording.